going to be on. The 40% of your paper is going to be based on, it's going to be based on organic chemistry. So starting with the very first thing, starting with the very first basic thing. That is, it's going to be, let's start with, I'm not going to start with alkanes. Let's start with carbon's hybridization. And how does carbon bond? Okay, so there are two, three different ways in which carbon is hybridized. So there is sp3 hybridization, which is so what is basically hybridization? It's kind of the shape of the molecule, the way the electrons around the carbon atom are distributed. Carbon has a total of six electrons. There are four electrons in the outer shell. There is 2s1, 2px1, 2py1, and there is 2pz1. Now, the carbon atom needs four electrons to complete its outer shell. So it can either do that by making four single bonds. So when carbon makes four single bonds, it is what is the hybridization when it forms four single bonds?
sp3.
Okay, so that is yes, that's sp3. So that one is sp3, and in sp3, you've got the tetrahedral arrangement in sp3 hybridization. One second, let me connect this with. So in sp3, you've got. TK, you need to know how to draw the shape of a sp3 hybridized carbon atom. So let's put it there. So TK, that's enough. So that's sp3 hybridization, and that's what tetrahedral arrangement. The angles are what 109.5 degrees. It's a three-dimensional shape. One of the bonds has to be a dotted bond. Okay, so let's make this one dotted. So for example, CH4, that's sp3. And so what happens when carbon is making a double bond, a single pi bond? Then it's going to be sp2 hybridization. Carbon would share uh, three of its electrons. You can remember out of four, it's going to share three of its electrons in, and the arrangement would be trigonal planar. That's going to be fan shaped. So carbon would be making three bonds, and there's a carbon in the middle, and there's going to be a p orbital that will be. There's going to be a fourth electron. So three of the orbitals will change shape, while the fourth is not going to change shape. So it's going to have this extra electron that will initially not be bonding. So it will have three hybridized orbitals, sp2, and one of the p orbitals would remain completely unchanged. So that is known as sp2 hybridization. So three of the orbitals are going to change their shape. The electrons are going to get pulled in three different directions. So you start giving them new names. So you're going to have three sp2 hybrid orbitals, and there's going to be one orbital which is unchanged, and that's going to be your p orbital. And that p orbital is used for pi bonding. Okay, this one is going to be used for. It's going to be helpful in making pi bonds. And over here, in the other one, there are three sp3. All four change shape. So basically, you've got four sp3 hybridized orbitals. So in this case, I've got these four orbitals, four electrons, and all four they change their shape. They get pulled in four different directions. So and all of them they become identical. So you start giving them new names. Start calling them sp3 hybrid orbitals. ठीक है. And what is the definition of hybridization? It's the mixing of orbitals during bonding to form new hybrid orbitals. To form new hybrid orbitals. ठीक है. Is this clear? This is your O layers. ठीक है. Is this clear? That's sp2 hybridization.
Yes,
Yes,
sir.
sir.
And then there's another one which is sp hybridization. In sp hybridization, what happens is that there's a carbon atom, and in that the carbon atom makes two bonds. Two of the electrons they get pulled in two different directions. So there's a bond that's being made on the right side, and there's a bond that's being made on the left side. ठीक है. And there'll be two orbitals that would not be doing anything. So you're going to have one electron, and there's going to be another p orbital that will be on the z-axis. So there's going to be another one that will be on the z-axis. So there's going to be an sp orbital, there's going to be an sp orbital, and there's going to be two p orbitals that will initially remain completely unchanged. So out of the four electrons, now what happens is in sp hybridization, only two of them are going to change shape, while the other two remain completely unchanged. So the two of them, they get pulled in two different directions. They become sp2, sorry, sp. And sp hybrid orbitals, the other p orbitals, they remain completely unchanged. The angles over here, this one is going to be linear, and the angle would be 180 degrees. This one over here, the middle one, sp2, that's going to be trigonal planar. It's going to be fan shaped. The bonds would be fan shaped. The extra p orbital, the fourth electron, will be forming a pi bond, and the angles will be 120 degrees. So that's the three types of hybridization of carbon atoms. See, so the four electrons get pulled in four different directions. That's sp3. Three of the electrons they bond, while the fourth electron is remains in the p orbital, which is then used for making pi bonds. So that's sp2. And the third one is that carbon makes two bonds. So one electron goes in this direction, one electron goes in this direction, while the other two, they're not doing anything. So the two electrons over there, that they'll be making pi bonds eventually. Okay, so is this clear? This thing?
Yes, sir.
Okay. So, so you've got three types of carbon atom. Now we're going to jump to the first one. We'll first initially do alkenes, and we'll cover all the reactions of alkenes just for the sake of revision. So, so I'm starting with alkenes. TK alkanes is the same as before. So in alkenes, you've got sp. I say alkenes. Whatever you study, that's going to be very close to alkenes. Alkenes are like really important. So alkenes, the carbon is going to be sp2 hybridized. ठीक है, it's going to be sp2 hybridized, and so this is what your typical alkene would look like. For example, if I have ethene, so there's a carbon atom, and that carbon atom is it's going to make one bond. It's going to make another bond. I'm drawing the exact sp2 hybridized shape, and then there's going to be a third bond. So something like this carbon atom would look. So it's going to look something like this. And the fourth electron will eventually be making a pi bond. Just one second. So the fourth electron will eventually be making a pi bond. Just one second. ठीक है. So I'll have another carbon atom, and so I've got two carbon atoms. Both of them are sp2 hybridized. ठीक है, let me correct this. This is my other carbon atom. Both of them have a p orbital. ठीक है, so that's because those are my p orbitals. The other carbon atom has exactly. ठीक है, so out of four electrons, three of them are making the usual. They're making the usual bonds. Now the two carbon atoms. Now remember, you have to be very careful. They're going to ask you. They're going to ask you this in detail, like who's bonding to what. In the middle, the sp2 hybrid orbitals would overlap, and वो कौन सा bond बनेगा? They're going to form a sigma bond. ठीक है, so these are your sp2 hybrid orbitals, and they would overlap in the middle. So the two atoms. Okay, let me draw this again. Okay, so the two carbon atoms would overlap exactly in the middle, and the sp2 and the sp2 would overlap right in the middle. ठीक है, so let's say that's overlapping happening. ठीक है, and so now remember, this is going to be very important. ठीक है, you'll be asked about this. It's not just AS. You'll be asked a lot about this in A2 as well. So the middle part is where your sp2 orbitals overlap with each other. ठीक है, from the neighboring carbon atoms, the two orbitals would overlap. Who's overlapping with the other side? If it's ethene, it's going to be a hydrogen atom that's going to be overlapping. Its electrons will be overlapping over here. So what you'll have is an sp2s orbital overlap. The hydrogen atom has an s, so it's an s orbital of a hydrogen atom overlapping with the sp2 hybrid orbital of a carbon atom. ठीक है, is this clear? This thing, ये clear है?
सर आप इसका दोबारा ओवरव्यू कर देंगे?
ये clear था that in sp2 hybridization, carbon has three electrons that are bonding, and there's a fourth electron which is in the p orbital that is not doing anything. ये clear
यस.
है? And the shape of the three bonds, that's 120 degrees, and that's trigonal planar. ठीक है, that's fan shaped. So there's another carbon atom. I'm trying to make an ethene molecule. The two carbon atoms would join in the middle. Okay, so that means okay, an sp2 orbital over here and an sp2 orbital over here, they'll start sharing electrons. They'll start overlapping. Is that clear?
Yes.
अच्छा side पे what is this carbon atom bonding to? It's an H, right? This is what an ethene molecule looks like. Okay, it's bonded to an H. So the sp2 orbitals on the outside that are going on the outside, they are overlapping with the H atom, right? So which orbitals are overlapping? It's the s orbital. Hydrogen has an s orbital. ठीक है, it has one electron. That overlaps with the sp2 orbital over here. Is that clear as well?
Yes.
So बस ठीक है, that's so you need to know कि what overlapping is happening in each of the bonds.
ठीक है
ठीक है.
सर.
So is this clear to everyone? Maheen, Amna, is this
Yes,
clear? ठीक है.
yes, sir.
Okay, so the next thing is what happens to the p orbital that initially in sp2 hybridization was not doing anything. ठीक है, you had a p orbital. No one was bonding to it. It was making three bonds. The fourth electron of carbon was not really doing anything. So what it's going to do is it's going to they're going to overlap and they're going to form a pi bond. So there's going to be overlapping that will eventually happen, and the electrons will overlap and they will form a ठीक है, they're going to form a pi bond. So they will eventually overlap and the pi bond would be formed. ठीक है, let me ठीक है, so the electrons in the p orbital would overlap and they'll form a pi bond in the middle. ठीक है. So who's forming the pi bond? The pi bond is going to be formed when a p orbital overlaps with another p orbital of the neighboring carbon atom. ठीक है, so that's a p and p overlap. So is this perfectly clear? Remember, you have to be very specific. It's kind of they're going to ask you very, very specific questions about the bonding over here. Is that clear?
यस सर.
Yes, sir.
ठीक है, so that's what an alkene is. The alkene molecule has a very strong electron density over here. There's a lot of electrons over here. So, so what the alkene has, it's got a very high electron charge density in the double bond. ठीक है, there's a sigma bond. ठीक है, let me write okay, which ones are sigma bonds. These are all sigma bonds. Uh, all of these were sigma bonds. But hopefully you already know this. They're all single bonds are all sigma bonds. You get the bond in the middle, that's a sigma bond as well. So there's a high electron charge density in this double bond. So who gets attracted to an alkene? Is it electrophiles or is it nucleophiles? But if there's a lot of electrons in the middle,
न्यूक्लियोफाइल्स.
the electrophiles. Electrophiles are attracted to electrons. ठीक है, so this high electron charge density in the double bond, it strongly attracts it strongly attracts what electrophiles. ठीक है, clear electrophiles are going to be attracted to electrons, right? Is this clear? And do you know what the type of reaction for alkenes was? That was what? Electrophilic addition reactions. ठीक है, we're going to go over them shortly. So they were electrophilic addition reactions. ठीक है, so is this clear up till this point? We just went into a bit more detail, otherwise it's all AS. Is this clear?
Yes, sir. Yes.
I said now the next one. Now the reason this is important is because The thing that we're going to study a lot in organic chemistry now is that it's benzene. And the benzene molecule is very similar to this. It's very sim it's basically like it's like an alkene. It's almost like an alkene. So we're going to compare the structure of an alkene and the reactions of an alkene eventually to this new structure, which is going to be benzene. Okay, benzene is known as an aromatic compound because they've got nice smells. Okay, that's why they refer to as anything that's got a benzene in it is aromatic. It's going to have an aroma. Okay, and benzene is like a very stable compound. It's a very stable structure which is present in a lot of molecules. Okay, almost pretty much everything has benzene in it. So what is benzene? The basic structure, if you want to understand benzene in the most basic way, it's basically six carbon atoms in a cyclic structure, and they are forming alternate double bonds. So they're arranged in a cyclic structure, and they've got alternate double bonds. Okay, that's the most basic idea of when you think about a benzene. And the carbons are short of, I mean, all the carbon atoms, they need one second. So ठीक है, I guess. So all the carbon atoms they need one more bond. So let's say that's each. As a first thing, can anyone tell me what the hybridization of benzene is?
So sp2.
ठीक है, that is sp2. Whenever there is one double bond, it is sp2. It's exactly the same. Whenever it's making one double bond, right? Uh, like when a molecule makes one pi bond, that's sp2. When it makes two pi bonds, let me write two over here. So when you've got two pi bonds, that's sp, and when there is no pi bond, then that's sp3. So benzene is sp2 hybridized. ठीक है, the carbon it is sp2 hybridized. So all these are sp2 hybrids. This is the exact structure. It's trigonal planar, and all the angles are 120 degrees. So it's a completely planar molecule. You can remember, focus on the term planar. That it's not going to be three-dimensional. It's going to be two-dimensional. ठीक है, अगर इसकी if you look at the actual picture of if you have a molecular model, for example, somewhere, just one second. So something I just wanted to show you that it's going to be. So it's just going to be a completely flat molecule. Yeah, this one. This one is fine. Okay, this is the actual geometry of the molecule. That's going to be completely plain. It's not going to be. It's not going to be. It's not going to be three-dimensional. Okay, now that's the first thing. So remember, imagine benzene. If you want to simplify things, imagine benzene like this. It's like an alkene, a cyclic alkene with alternating double bonds. Okay, that's the most basic way of understanding. And this is like, I mean, it kind of helps you understand what the structure or what the hybridization is, who's making how many bonds. So it kind of tells you, but this is not the actual representation. This is kind of a wrong representation. So we're going to move towards the more correct representation. Okay, that's not the true story. But remember, this is going to be very helpful. So I'm just going to write it as the wrong representation, but it's helpful to figure out who makes how many bonds and what the hybridization is. Now the correct one is that all these carbon atoms are sp. So we're going to draw the correct structure now. So remember, it's sp2 hybridized carbon atoms. Okay, I'm gonna pick the same carbon atoms. Okay, the ones over here. Okay, I've got both types of carbon atoms, so I'm gonna pick those. So it's six of these carbon atoms. So that's carbon number one. Then there's carbon number two. Let's pick that. Okay, that's going to be here. I said then there's another carbon atom which is going to be sp2 hybridized. Then there's going to be one second. I said so there's going to be six. All of the carbon atoms are making double bonds, and there'll eventually be six of them. So again, the detail is important. So यहाँ तक, is this clear up till this point that in benzene there are six carbons and all of them are sp2 hybridized? Is this clear?
Yes, sir.
ठीक है. Saro clear? Zaina, is this clear? Zohair, everyone, is this clear? Achha, so what's going to happen next? It's exactly the same what happened over here. They're going to start bonding with each other, right? So the sp2 hybrid orbitals would start overlapping. I'm just going to rub off the so that it doesn't get messy. So just remember these are all sp2 hybrid orbitals, and there's a p orbital that's in the middle. So they're going to start forming sigma bonds. The outside sp2 would form bonds with it's going to form bonds with hydrogen. So first these two, they'll overlap, and okay, so they're going to overlap. Okay, that's one. These two would overlap. Then this one would overlap. One of the bonds would overlap, right? So let's say it. I guess that's it. So इसका भी उठा दिए. One second. ठीक है. You'll be asked to draw this as well. So these two would overlap. This would come in, and this would start overlapping, right? So they'll start overlapping in the middle. Okay, throw. So let me. So these two would come in, and they'll probably start overlapping as well. So I guess that's it. And then this would come in, and the sp2 hybrid orbitals would start to overlap. Okay, perfect. So that's my planar ring. Six carbon atoms forming a ring. So is this clear? This one?
So, sir, will they ask us to draw this in the paper, like this
हाँ,
presentation?
they can ask you. I mean, they can ask you to draw this. ठीक है.
Okay, sir.
And they would ask you to explain this as well fully. अच्छा, so the middle part is that all these sp2 orbitals are overlapping. ठीक है, they're joining up. So this is All of these are sp2 overlap. Okay, this one is also, let me just write it quickly. Okay, this is sp2 and this is sp2 overlapping, right? So what is happening on the outside? The outside, the sp2 orbital that was on the outside, that's bonding with the H. So they're all bonding with hydrogen atoms. Okay, that's on the outside. What is that overlapping? That's sp2 overlapping with an S. Okay, but you can, all the others are also sp2 overlapping with an S. Now, what happens to the p orbital? ठीक है वो जो unchanged the p orbitals that are in parallel they start forming pi bonds. So they can form so they're going to form pi bonds. That's one pi bond formed. ठीक है then these two can overlap and they'll eventually form a so they'll eventually form a pi bond. ठीक है then these two would overlap and they'll form a pi bond. So this one overlaps with this. And they form a pi bond. So three alternating double bonds form, right? Is that clear? This thing.
Sir, what about the middle one जो बीच में उनके pi bond नहीं
हम
बनेगा?
मैं वही कह रहा हूँ. अच्छा, so what happens basically is that at the end of the day, it's all of them they end up overlapping. The three double bonds they get delocalized. Because if you look at this p orbital over here, if it can overlap on the right side, it can also overlap with the carbon on the left side. This is known as a resonance structure, or basically you can think of it as a delocalized electron cloud. So what eventually happens is okay, even the middle ones they start overlapping. So the orbitals are partially overlapping on the right side. They're also overlapping on the left side. So they all eventually start to overlap. And you get a delocalized electron cloud. You get these two also start to overlap. So is this idea clear that you don't actually have three double bonds? Okay, it's a good way to sort of figure out the structure, but it's you don't really have three double bonds. What you have is three delocalized double bonds. The electrons are everywhere. Okay, they're all delocalized. So is this thing clear to everyone?
Yes, sir.
Yes, sir.
Okay. So and let me okay, so the overlapping is going to be everywhere. So all of them will eventually overlap. So the double bonds, the pi electron cloud is now completely delocalized. Just 1 second. So there's a ring of delocalized pi electron charge density or pi electron cloud. That's known as the benzene ring. Okay, that's referred to as the ring of benzene. And now we're going to talk about the proper way of writing this. It's not going to be three double bonds. The way it's going to be written is, let me push this down a bit. Okay, the way it's going to be written is, okay, 1 second. So the way this structure should be written properly is that so this thing, you don't show double bonds. Instead, what you do is you show a ring. Okay, that ring kind of shows that there's a delocalized pi electron cloud. Okay, so that ring kind of shows that all the double bonds are mixed up. Okay, is this part clear? Saruko, is this part clear?
Yes, sir.
Yes, sir.
Okay, that's your correct representation. That's the correct way. I said now they're going to ask you everything about. They're going to ask you. It's going to be a big question, like a 4 to 6 mark question. They're going to ask you to describe the structure, either draw it or describe everything, right? So you're going to write everything about this. You're going to talk about, for example, if it's a 6 mark question to describe this, right? So you're going to talk about the first thing. You're going to tell them that carbon is sp2 hybridized, right? You're going to tell them that the geometry of each carbon atom would be trigonal planar, and the angles are going to be 120 degrees. You're going to tell them that the carbon-carbon sigma bonds, how are they formed? They are formed when sp2 overlap. You get the middle carbon-carbon sp2 overlap. You're going to tell them that the carbon and hydrogen sigma bonds, how are they going to be formed? They're going to be formed when the sp2 overlaps with the s orbital coming from hydrogen. Okay. Then how is the delocalized pi? You're going to tell them that the p orbital and p orbital overlap, so the pi electron cloud. How is that formed? That is formed when 6 of the p orbitals they overlap with each other. 6 of them. Okay, they all overlap. So all 6 p orbitals overlap sideways. Okay, or we can add that overall the structure is that it's hexagonal planar. So the geometry around the carbon atom is trigonal planar, and overall the entire structure is going to be the overall geometry would be hexagonal. It's a hexagon, it's a regular hexagon, planar with 120-degree bond angles. Okay, so is this clear that this is how you're going to describe the structure of benzene? You clear, Saruko? Is this clear?
Yes, sir.
We need to draw the structure of benzene also.
But it's your choice. They might give you space to draw the structure, to describe the structure, or you could simply just write what the answer is. Okay, so they'll give you both options. Or there's sometimes they ask you to show how the pi electron cloud is, so you can sketch that. Actually, I haven't seen a question where they ask that, but they normally do give you space to sort of draw the structure. I mean, that's an option. Now now there's one very important thing. Okay, remember we've done both pi electron clouds. Okay, there's just the last thing. There's an alkene pi electron cloud, 2p orbitals overlapping, right? in the middle. And there's a benzene pi electron cloud. It's 6 p orbitals that are overlapping side by side. Can you tell me whose electron charge density is higher? Alkene or benzene? Anyone?
Sir, benzene?
No, it's alkene. Okay, remember charge density is how concentrated the charge is. Okay, in alkene, the the two p orbitals they overlap and the electron charge is concentrated in the middle. Okay, that's why it's got a higher charge density. Over here, what happens is that the p orbital is overlapping on the left side. It's also overlapping on the right side. Okay, so that means that its electrons are more distributed. Okay, they're more spread out. Is this idea clear? Okay, compared to an alkene, alkene has a much higher charge density because both p orbitals, the electrons are like concentrated in the middle. But over here, the electrons are more spread out. Okay, the p orbital is overlapping on the left side. It's also overlapping on the right side as well. So half of the electrons are going on the right side, half of the electron charge density is going on the left side. So it's the electrons are more spread out. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. So that's just the last thing. Okay. The way benzene is going to be different from an alkene is that the pi electron, where's the pi electron cloud? So this pi electron cloud has a lower charge density. So it's got a lower charge compared to alkenes. Actually, it's much lower. So there's going to be less attraction for electrophiles. Hence, it will be more stable as well. Because it's not going to be that reactive. Like if you have a lower charge density, you're not going to attract electrophiles. That means you're not really going to do a lot of things. So which is why benzene is a much more stable structure. Alkenes are less stable. Alkenes are very reactive. So it's going to be more stable. It's going to be less reactive compared to alkenes. And so just remember that the pi bond that's being formed over here and the pi bond that's between an alkene, they're not exactly the same. This has a much higher charge density. This has a much lower charge density. This has a much stronger attraction for electrophiles. This one doesn't really attract electrophiles that much. Okay. Is this clear? This thing?
Yes, sir.
So ठीक है बाकी we'll continue
Yes,
tomorrow.
sir.
ठीक है, we'll continue tomorrow. Any questions about this? Is this 100% clear to everyone?
Yes, sir.
So,
Yes, sir. Sir, can you add me to this one note?
हाँ अच्छा अभी बोल के बता दो अच्छा चलिए the rest of you can leave ठीक है let me just add some people to OneNote 1 second अफान की जाना